Right. Good evening, everyone. I am Ziran Liu, a freshman at Pittsburgh College and the former president of Outreach Helping Hands.
Hi, I'm Anna Lee, a freshman or incoming freshman at UCLA, and also a member of Outreach Helping Hands. We're excited to welcome you all to tonight's presentation.
Tonight, we are happy to have Lucy Zhang as our guest speaker. Lucy is a rising junior at Oxford Academy with a profound love for her logic of mathematics. She is a two-time USAML qualifier and a Ross and Sumac alumnus. Through her experience tutoring peers and younger students in both traditional and competitive math, she began to notice the unique, diverse ways students process concepts and solve problems.
Thank you, Ziran. Today, Lucy will be presenting Dyscalculia Beyond the Numbers, where she will dive into this lesser-known disability that impacts 1 in 20 students worldwide. You'll be exploring everything from cultural myths and neurobiology to systemic advocacy. As she presents, feel free to leave your questions in the chat. Welcome, Lucy.
Thank you so much. Let me share my. Hi, sorry, I was unmuted. So hi everyone, I'm Lucy. I want to thank Zen and Anna for inviting me today. And today I'm going to be talking about dyscalculia. I originally found out about this disability through tutoring kids. And when I found out about it, I was really surprised because I've been in the math community for so long, and just not even hearing a whisper about this disability was really something I thought was important that we need to acknowledge. And also, I wanted to share more about SLDs, which stand for Specific Learning Disabilities. And dyscalculia falls under that umbrella. And there are many disabilities classified as SLDs that are also less known. For example, dysgraphia. And these are all disabilities that impact children in unspeakable ways, and we need to provide awareness that will eventually get these children the help they need. So first I'm going to be talking about what dyscalculia is. First, its etymology. So dys stands for difficult, and calculator means to count. So dyscalculia itself means to be bad at counting. And according to the disability and the disability classification that is the most prominent in the US, it's called Diagnostic and Statistical Manual for Mental Disabilities, also known as DSM. It is categorized as a specific learning disorder. So we, as clinicians, they classify most of the problems that people experience neurologically as disorders, but educators would call them disabilities. So that's just to clear up the naming difference. But dyscalculia is classified using DSM as an impairment in mathematics, especially in number sense. So the sense of numbers, memorization of arithmetic facts, accurate or fluent calculation, and accurate mathematical reasoning. So looking down below, there is a line of dots under this text box. Somebody with dyscalculia would struggle to see that there are 6 dots below the screen. They would have to count with their hands, and it would take them around 5 to 10 seconds to understand that there are 6 dots on the screen. And moving on, we have prevalence and dyslexia gap. So there is a large gap between the amount of people that have dyscalculia and the amount of people getting research in dyscalculia compared to dyslexia. So dyslexia, I think, is something that almost all of the audience knows. It's when students have an impaired sense of reading comprehension and literature. So they struggle with reading text, writing text, and understanding what is being said when they read the text. And about 10 to 15% of the population of humans that are in education right now have dyslexia, and if we compare that to dyscalculia, which is around 5 to 7%, it's about twice as much, but dyslexia gets 10 times the amount of research funding and clinic trials that dyscalculia does, which we see is a disparity that isn't really fair. In addition, we see that teacher preparation programs, which are programs that teachers attend when they are aspiring to become future educators or they want to become future teachers, they have to attend these so that they learn how to teach. A lot of these programs spend around 200 instructional hours teaching them about specifically phonetics and reading comprehension compared to around the 80 to 100 hours of required instructional hours that aspiring teachers need to take in order to become teachers in their respective categories. And lastly, a disparity is public awareness. And the reason why public awareness is so important is because in order for people to get the proper help they need to first have people in that area currently studying it. And in order to have research, they need to have funding, and funding comes from public awareness and people knowing that something like this exists, and then putting money into these scientists that want to research it but need the funding. So that's why we try so hard to get awareness in all types of different disabilities and all types of different gaps that are missing in research, because with public awareness comes better research, and with better research comes better solutions to how we can fix these problems. And next, I'm going to talk about the neurobiology of the brain. So first, the neuroanatomy. So dyscalculia is in fact something that isn't visible when we look at a person just looking at them, but we can see them in medical scans, and we can see them in, for example, MRI imaging. So the specific part that you can see that is different from normal people is that the intraparietal sulcus, also known as the IPS, that separates the parietal lobes into the superior and inferior, has reduced gray matter, and they also show less neural activation when they are trying to number process. And this is something that tells us it is in fact, dyscalculia is in fact a disability. It isn't something where the student isn't trying hard enough. They aren't putting enough effort into what they're trying to learn. And the most important part of this is understanding where dyscalculia stems from, because the IPS is responsible for non-symbolic magnitude comparison, which is exactly what number sense is to connect the magnitude or the numerical value of something to the word that the number is correlated to. For example, if I give you 3 dots, you should be able to tell that the numerical value 3 is related to the word 3. And next, I'm going to talk about some things that are caused by a reduced gray matter in IPS. So subsitizing deficits. Subsitizing is the ability to recognize the number of objects in a group without counting them. So for example, in the experiment in the first few slides, I showed you a group of 6 dots, and you had to if you look at these dots, you should be able to tell immediately how much dots there are. But people with dyscalculia struggle to do that. And we commonly see this when we're playing board games. For example, Monopoly, when you roll dice, you should be able to tell immediately from the top of the dice what the number is. But when you have dyscalculia, you struggle because you can't tell from just looking at the number of dots on the dice what the number is. And other examples would be looking at dominoes. So if you ever look at dominoes, there's dots, but you should be very easily be able to tell how much dots are on a domino piece. But if you have dyscalculia, you would have a hard time. And another example would be looking at fingers. So when you're in elementary school, a lot of the times teachers would utilize holding up fingers to connect number magnitude with the number itself. And it would also be a fun game. And it would also help with students struggling with um, hand coordination. And when students with dyscalculia are tasked with reading how much fingers is somebody holding up, they would have trouble connecting the image of the fingers with the number. And another impairment that stems from having reduced brain matter in IPS is working memory load. Working memory is a brain system that lets you hold a small amount of information for a short amount of time when you are doing some operation. For example, in multi-step problems, if you're trying to multiply double digits, you would have to memorize for a very short amount of time what is the number you're carrying over to the next digit when you're doing calculations. And people with impaired working memory would struggle to do that, and thus they would struggle with multiplying double digits. And that is exactly what people with dyscalculia often experience when they are trying to do calculations. And this impacts multi-step math because once you get beyond basic computation and you go into solving word problems or solving multiple variable equations, you have to memorize a lot of information when you're moving between the different problems. For example, in word problems, when you read a word problem, there's a lot of things that aren't important and there's a lot of things that are important. And when you read through it and then you forget the important parts, you have to keep going back to the problem again and again just to see what are the numbers that I need. And when you have dyscalculia, you don't remember where information is located in a block of text, which means you have to read it again just to find one piece of information. And then if you have this piece of information and you need another piece of information, you have to read it again. Which is why when you are formally diagnosed with dyscalculia, during tests like standardized testing, such as SAT and ACT, you are given extra time during these tests because test writers are aware that you have to spend more time going back because of your disability. And one last thing on working memory is that there are different types of working memory that are impacted by reduced brain matter in IPS, and one of them is verbal IPS. So it's holding something verbally in your brain when you are trying to do something else. For example, you want to log into a Google account and you get sent a verification number. This verification number, you kind of repeat it to yourself in your brain, and then you go back to the tab that you're trying to verify your identity on, but then you forget because your working memory is impaired. So that is an example of working memory. And another part of working memory that is impaired is visual spatial working memory. So that would be like understanding the distance between the like a block and like two blocks on a table. You would have like problem remembering what the distance is when you're trying to calculate another part. So say, for example, you're driving and you see a curb that you want to parallel park next to. You would have to constantly be looking at the curb and then looking back at your steering wheel and looking at odometer because you struggle with remembering these numbers. And next, I want to talk about overlap. So overlap is something that happens very commonly with neurological disabilities and disorders because everything happens with impairments in the brain and just differences in how different parts of brain regions are interconnected. So ADHD has a 25 to 30% of people with ADHD also have dyscalculia because they both have problems with the brain area, ADHD being in the prefrontal lobe and dyscalculia being in the IPS. And not all ADHD stems from uh, the same problems that dyscalculia comes from, but they both overlap in the sense that when somebody with dyscalculia is trying to learn math or a mathematical concept, they would struggle to pay attention because of their working memory. And in the same way, people with ADHD would struggle to learn because they have attention deficit. And dyslexia, which is another specific learning disability, has an overlap of around 40 to 50%, meaning that someone with dyslexia has a 40 to 50% chance of also having dyscalculia because the problems in the brain also appear in the IPS. And so when that happens, people with dyslexia should be tested to see if they have dyscalculia. Not saying that if somebody has dyslexia, they automatically have dyscalculia. And one last thing is developmental coordination. So developmental coordination is often the nickname for spatial dyspraxia, which is relating to impairments in the visual spatial part of the brain. So the difference between how a person understands space and distance and their body's position in this world is related to understanding the mathematical magnitudes that come with distance. So for example, if you look at something 4 feet away from you and 10 feet away from you, you would be able to tell that something is farther away because you understand the word farther. You understand that the conceptual meaning behind farther. But someone with dyscalculia, for example, would struggle with visual spatial understanding because they aren't aware of the magnitude concept. And then we can go on to age-based indicators. So dyscalculia reflects itself differently in different ages. And in preschool, which is around 3 to 5 years old, students are already beginning to interact with math concepts. They should be able to sequentially count to 10, no problem. And they shouldn't struggle with mixing up, like they don't count 1, 2, 3, 5, 4, for example, but people with dyscalculia might show signs of difficulty counting sequentially up to 10, for example. And other times they would have struggle with looking at a group of objects and they wouldn't be able to say the correct numerical value. For example, they point to a group of 4 chairs, they might say 5 chairs because they haven't connected the numerical magnitude with the word yet. And those are just two of many different signs that you may see when people are looking for signs of students with dyscalculia. Next are elementary indicators. So this is the age range where people really start seeing a gap between the people that have dyscalculia and people that are neurotypical. So they in preschool, a lot of students rely on finger counting, but by the time they get into elementary school, they should be able to do mental math, at least in single digits, pretty easily. And they should also be memorizing their times tables and addition tables by the end of elementary school. But we see a lot of people with dyscalculia struggling to do these types of things even by the time they're in middle school. And we can see on the bottom of the screen are some examples of how people with dyscalculia would view numbers. So they would mix up how a number is written. For example, you see on the second image, 3 is written backwards because they haven't truly understood the concept of the numerical value 3, and they mix it up with the word 3, and they mix it up with the symbolic value of 3. And we can also see they make mistakes when adding or subtracting double digits because they haven't truly understood digit, like the concept of digits, where there's ones digits and tens digit, and those things are different, and you can't just view them as separate parts of a single number. And one last thing you see when you try to look at the people's math when they have dyscalculia is they mix up operational signs. So if they're asked to do subtraction, they might do addition instead. At middle school, the problems become very apparent because students start advancing into word problems and they start advancing into real world problems, such as physics-based problems. And when that happens, students really start struggling with being able to catch up with their peers and being able to understand concepts when teachers are teaching them. And lastly, high school hurdles. This is at the point where students aren't really able to meet the level which they are supposed to compared to their peers, no matter what the teacher tries to do, given that they're not get put into special education, because at that point you need to one very important skill, which is algebraic abstraction, which is adding variables into the math you do, such as algebra, geometry, and calculus. And when that happens, people with dyscalculia face really big cognitive resistance, meaning that they aren't able to understand why abstract numbers are being placed into math because they haven't even truly mastered numerical values and number magnitude. And that leads to a bunch of secondary impacts, such as in their geography classes or their history classes, they struggle with reading graphs and charts and being able to conclude information from visual representations of data. And obviously in chemistry and physics and biology, they would struggle with labs and formula sheets, and that leads to a lot of problems when they are doing their standardized testing, such as AP, SAT, and ACT. And that, along with severe bullying, because a lot of students are now more aware of physical disabilities, but not so much mental disabilities. They might get bullied for being dumb or not putting enough effort into their studies. They might stop attending school entirely, not even just math class. And that leads to a lot of social problems and emotional problems leading on into adulthood. And then we can talk about adult life hurdles. And something very obvious would be budgeting. So even adults that don't have dyscalculia, they struggle with taking care of their financial responsibilities. People with dyscalculia would have even more trouble. And tipping at restaurants and managing your loans and interest and investments are all financial responsibilities that people with dyscalculia would have a lot of trouble with. And another part of dyscalculia is blindness in time. So in order to understand the term tomorrow, you have to understand that tomorrow is somehow numerically greater than today, and yesterday is somehow numerically less than today. But because you are unable to understand number magnitude, you are unable to understand the concept of time. So people are often late to appointments when they are in their adult life, and they struggle with managing their time correctly. And that leads to a lot of problems in their professional life and personal life. And lastly is spatial navigation is, again, because of the lack of understanding in numerical magnitude, people would have problem driving and their orientation around them. And that would often cause them to struggle with getting their driver's license, for example. I've met people with dyscalculia who would, before their driver's test, use nail polish and paint L and R on their hands because they don't truly understand what left and right are. And now to diagnostics and assessments. So there are ways to get diagnosed with dyscalculia, because getting diagnosed with dyscalculia gives you a lot of accommodations that people normally are not able to have. So one way would be contacting a neuropsychologist. So these are clinical specialists that focus on brain behavior or brain related disabilities. So they would test your cognitive ability and your brain functioning ability, And from there, they would give you a formal clinical diagnosis that allows you to that gives you a physical referral to any workplace problems or any educational related problems that you meet when you are trying to navigate life with dyscalculia. And the second option is through a school psychologist. So as a public district, all public districts are required to provide a school psychologist to all the students that are in public schools. But the problem is there's usually one school psychologist per district, meaning that psychologists spend their time in different campuses. So if you want to contact a school psychologist, you would have to first talk with your school's admin, and then the admin, if they don't get back to you, you should directly contact something that is called the school district's psychology department, where there would be people that specialize in mental health, people that specialize with mental disabilities, and people that specialize with learning disabilities. And through that, you are able to collaborate with both with your school teacher, your school admin, and the school psychologists to develop an IEP plan, and also be given 405 accommodations that allow you to get special referrals during standardized testing and just normal school testing that gives you extra time and tools such as access to calculators when you are navigating your educational journey. And intervention and pedagogy. So these are the education that you get with a public school and the education you get with a special ed school are very different. And one of the most important ones is that special ed schools use something called the CRA model, which takes you through 3 steps to get to a true understanding of a concept. So first is concrete, is using physical objects such as base 10 blocks to teach you a concept of digits, and then using representations such as visual images. So moving these physical objects and then drawing visual representations of them on a piece of paper, and still being able to apply the skills that you develop using these physical objects and applying them to the visual images. And finally, being able to use abstraction to put the visuals and applying them to mathematical notation. So abstractizing your mathematical knowledge. And this CRA instructional model is very beneficial to students that struggle with understanding concepts right away from teachers that are just teaching them on a screen without true connection with real life examples. And this concept is one of the most research proven models that help with students that are struggling with learning disability. And another technique is using multi-sensory math techniques. So because people with dyscalculia struggle with connecting mathematical magnitudes and mathematical concepts to the word and numerical value, connecting this mathematical concept with another concept that you are very familiar with helps students learn and remember more clearly. So for example, kinesthetic is connecting physical touch and body movement to learning math abilities. So one example of that would be if you put a piece of tape on the floor and then draw numbers and make it act as an enlarged number line, then you can ask students to jump around on the number line to simulate how magnitude is perceived in a person's dyscalculic mind. And other examples would be auditory and color coding. And lastly, I want to talk about systemic advocacy. So again, a reason why we want to advocate for these diseases and disabilities and disorders are because with awareness, you are able to provide funding to research centers. And with research, you are able to find better intervention and better resources to people with these disabilities. So One of the biggest things that people can advocate for is teacher preparation gaps and how school view how important it is to isolate these students with disabilities and giving them the proper treatment that they need. So around 50% of people that are trying to go into education are are instructed by reading specialists and are receiving a lot of instructional hours on how to approach students who struggle with reading comprehension and phonetics, but only around 15% of teachers have reported that um, their students were ever formally screened for math. And I can say from my own experience that I have been screened a lot of times in my elementary years on my reading comprehension, but I've never been screened for math. It would just be at the end of my elementary journey that I took one singular math test to test if I was okay to move on to middle school based on my mathematical abilities. So knowing these statistics, we need to advocate for more teacher preparation and also for more student intervention policies in schools when they are still young. Because when they're young, they aren't that far away from the peers around them, and they are able to learn with the right instruction how to connect numerical values to the word itself, and that would be really helpful, especially when they're moving on to adult life. And something that we can do is look at other high performing countries that have good math intervention policies. For example, Singapore, they would focus on fewer math topics throughout the year, and they would use CRA models on every single math, like educational institution. So that would ensure mastery for all students, and all students are screened at the start of primary one, which is like kindergarten. And if they lack basic numerics, like basic numeric concepts, they would be either placed, depending on their severity level, in Singapore's Ministry of Educational math program, which is specialized to help them with math, or they would be pulled out of class to talk with one-on-one with specialists on their math and their conceptual understanding so that they get the proper teaching that they need. And last thing we can advocate for is a dyscalculia aware classroom. So in a lot of elementary schools, students would often view having to use tools as something that makes somebody dumb. For example, in elementary school, if students still have to use calculators on single digit operations when most of their peers have already moved on to using mental math, a lot of stigma is placed around that student. So we need to normalize using tools as a part of the learning process. And in addition, because people with dyscalculia make so many mistakes on computational work, but they are completely capable of understanding logical approach, they should students and teachers should place more value on how a student approaches and a student steps to a problem instead of just your answer A, B, C, D, E, or if the number that you get at the end is right. And lastly, we can say we should use language shift. So instead of saying that's easy after mastering a concept, you should realize that before you learned this concept, it was hard for you too. You didn't understand either. It was only after you truly understand and master that concept that you think it's easy. So we should advocate for shifting your language into that's easy to, it takes practice, but eventually you'll get it with time. And with that comes to the end of my presentation. I want to thank you all guys for being here. And from my own experience, because I wanted to raise awareness on dyscalculia, I created a website and I published a book, and I'm in the process of developing an app that helps spread awareness and helps those with dyscalculia live a better life. So these are QR codes that you can scan to see what these are on. And any questions?
Thank you, Lucy, for that incredibly informative presentation. It's so important to move just beyond acknowledging dyscalculia and towards true awareness. And your resources that you have provided and breakdown of the dyscalculic brain and the lifespan indicators really helped bring that awareness.
That's right. We appreciate your dedication to advocating for the support of all students. And teaching parents and educators this knowledge is definitely the first step to real change. Now, let's start with some questions. How do you think AI will impact how students with dyscalculia learn in the future?
I think that AI will change education completely in a few decades, but as of now, teachers, human teachers, would still be having the interaction between students and teaching them concepts. But I think that would apply same for dyscalculia, where AI might start developing better intervention policies and they might start developing better curriculums. And they would also be able to provide more personalized feedback. It would still be teachers that are still talking with these students one-on-one because the emotional and social guidance that human teachers provide is essential to a student's learning.
And do you think that giving students with dyscalculia calculators for homework and tests will benefit them in the long run, or don't you think that they need to learn these skills as adults?
So I definitely think that calculators are very beneficial when they're used as accommodations, but most students that are given these calculators as accommodations already have some conceptual uh, understanding on what number magnitudes are, and they have already studied in deep depth how to do basic arithmetic. It's just that because of their disability, they struggle with repeated computational tasks, so that after they know how to do these computational tasks, they are able to use these accommodations so that they can spare their brain processing to higher level math, such as defining the step-by-step process to a problem and then using calculators to solve it.
What accommodations outside of the classroom are there, such as like in the workplace, for example?
Yeah, so accommodations for people with dyscalculia doesn't end with their education, but most accommodations that you see in your early life, it comes from your IEP plan, which is your educational plan that a psychologist and your teachers will develop for you. But after that, be you would have to talk with a clinician and you would have to be documented as someone with this specific learning disability. And using that, you are protected under Americans with Disabilities Act, which um, ensures that you are provided the proper accommodations um, in a workspace and you are given reasonable tasks depending on your job responsibilities. So for example, uh, companies might be able to provide uh, calculators that are specialized for people with dyscalculia and other software that is specialized so that it can help people with dyscalculia do their jobs that usually people with dyscalculia have to pay out of pocket for.
So, what would you say is the difference between having dyscalculia and being naturally bad at math? I know you said in your presentation that it's caused by abnormalities in the brain. What causes it?
So dyscalculia comes from many factors. Because of the lack of funding, and just because of not a lot of consensus among the people that are studying it, researchers believe that it is a combination of developmental and biological factors, meaning that some of it stems from genetics and some of it stems from uh, the things that happen to you in your early development, such as premature birth or young brain damage. Uh, and there has been studies that have shown that twins, if one twins, if one twin has dyscalculia, it is statistically more likely for the other twin to have dyscalculia.
I feel like that like most adults use calculators and Google for math questions. So why is it so important that people with dyscalculia learn math when is it so hard for them?
So something to remember when we are talking about dyscalculia is that they aren't able to connect a numerical value with the word. So they often struggle with doing things that most people don't need Google or calculator for. For example, if they're doing groceries and there was a problem with the register, if they see a bill that says $900 for like a couple of fruits and like vegetables, somebody without dyscalculia would automatically know that there's something wrong with the register and you need to get help so that you don't get scammed out of your money. But somebody with dyscalculia wouldn't understand how much $900 is, and that leads to a lot of problems, not just in groceries, but in things like in the workplace, um, planning out your schedule, so time management, and also interacting with other people.
So we have a question from Grace, and she said, really good job, and I agree. And she's also asking if you could tell us a little bit about how to publish your book, your process publishing the book.
So I originally wrote this book not because I like wanted to get it published. It was because I was actually researching about it and I was like, wow, there's so much information. But after I accumulated all these information, I realized there isn't one specific source that gives me all of this. So I decided to publish this book. I published it through BookBaby, which is something that allows you to uh, publish it for quite cheap, but you also get really um, cheap hard copies that you're able to give out to local libraries. So once I published my book, my main goal was to spread the word and spread awareness for dyscalculia. So I published it through BookBaby, and then I decided to distribute and donate these books to local elementary schools and local libraries.
All right, that's great. Celine has asked a question. Have you done any hands-on projects with or like interacted with people with this before?
Mm, Not yet, but I have personally tutored some students with dyscalculia, but it was really just with helping them with their work. We are planning, because I have a team behind Beyond Learning, and we are planning to um, implement some workshops at local elementary schools that give these students an understanding of what dyscalculia is and how students with dyscalculia view the world.
Yeah, thank you for that. And then going off of that, what are some signs a student has dyscalculia in their work?
So the signs that I've seen are they count with their fingers when they're doing really basic computational work, or when they're writing down numbers, they switch the place value. For example, if the number is with the question is 16 times 23, when they're copying the problem, they would write 61 times 23. So they would switch those. And they also like mix up operation symbols. So if I'm asking them to do addition, they multiply the numbers instead.
Does anyone else have any questions for Lucy?
I do have a question.
Mhm.
Um, is it is this meeting? I'm sorry, I didn't get the full meeting. I was late. I just wondering, is this meeting general? It's for the the students have a sort of a disease, or it's for general the student who kind of relies on the calculator too much. They are kind of lost their either capability of calculating skills. So um, which group of students are more concentrated?
Yeah, so this is actually meant for everyone because I wanted to do this talk because I wanted to raise awareness on dyscalculia. So anyone who is interested in learning about this disability, or if they suspect they have it, or if they think that they are struggling in math a little bit, I think uh, it's for everyone. Yeah.
Oh, okay, thank you.
Okay. Thank you, Lucy, for being here with us today. It was a great presentation, and you really raised a lot of awareness about dyscalculia. And if no one has any more questions, then I think we will be ending here.
Thank you everyone for coming to the presentation and have a good day.
Thank you, everyone.
Thank you.